In this video, Chapter 4, Section 3, Values of Trigonometric Functions, I'm going to show you how to get some of these values here, okay? So what we're going to do is we're just going to scroll up here, and we're going to start with a right triangle. And this right triangle here is going to have the following characteristics, all right? So the first is r is going to equal 2, and y is going to equal 1. We don't know what x is, okay? But what we do know is this angle right here is going to be 30 degrees, all right? So we can go ahead and we can find what x is by using our Pythagorean theorem. So x squared plus 1 squared equals 2 squared. Well, that's going to be x squared plus 1 equals 4. Subtract 1 from both sides, you get x squared equals 3. Therefore, when we take the square root of both sides, we get x equals the square root of 3. So what we could say here is the following. The sine of 30 degrees, remember, opposite over hypotenuse. So the sine of 30 degrees is going to be 1/2. The cosine of 30 degrees, now remember, that is adjacent over hypotenuse. So cosine is going to be the square root of 3 over 2. And then our tangent at 30 degrees, well, remember, tangent is opposite over adjacent. So it's going to be 1 over the square root of 3, which traditionally we rationalize the denominator to make it the square root of 3 over the square root of 3. So what we just found, and I'm going to scroll up here real fast, all right? If you look at the sine of 30, so let me highlight this for us. So we just found all those values. Remember, each ordered pair has the coordinates cosine theta, sine theta. So the cosine of 30 degrees is the square root of 3 over 2, comma, the sine of 30 degrees is 1/2, which if I just zoom out here a little bit, that's exactly what we have here, and I'll match it up with the highlighter. Cosine of 30 degrees, square root of 3 over 2. That's all the way down here. Then, the sine of 30 degrees is 1/2. Well, that's all the way down here. And then when you take the ratio of these two, you get the tangent. All right? And that is basically how we do all of these. All right? So I know it's a little weird at first when you see this, but this is how we find all of the angles. Now, the thing that I really want us to look at here, all right, is this. All right, so let me erase a bunch of stuff here. All right, and I want to just zoom in on this. Recall from algebra class that quadrant 1 means that all of your x comma y values are both positive values, all right? Therefore, that means sine and cosine will always be positive in quadrant 1, okay? Now, let's focus on one of these specific values, okay? Sorry, my screen went blank there for a second. I'm back. I want to focus on one of these specific values, and we're going to use the sine of 30, okay? So notice that square root of 3 over 2, comma 1/2, they're both positive numbers. However, if I just kind of reflect this about the y-axis, notice that we now have negative square root of 3 over 2, comma, positive 1/2. And that's because, if you remember, in quadrant 2, all of your x values are negative values, but your y values are positive. Well, in this case, in quadrant 2, all of your cosine values are negative, and all of your sine values are going to be positive. So you can see here, negative 1/2, negative root 2 over 2, and then negative root 3 over 2. Notice they're all negative, but they're all cosine values. Now, if we look down in quadrant 3, both cosine and sine are going to be negative. And then in quadrant 4, which is lower right-hand corner of the screen, cosine values are positive, sine values are negative. And that's going to play a role later on when we're looking at angles and trying to figure out, like, maybe what is the trajectory of this particle or something like that. Okay? So now, what I would like you to do is, using the same method that I did, I want you to find all the other ones just in quadrant 1. Because in reality, if you know quadrant 1, okay, you know all the other ones. All right? You know all the other ones. All you have to do is, like I said, just flip them about the y-axis and then flip them about the x-axis. And you'll find all of them. Okay? Next, what I want to go over is okay, well, what about if we use our calculator? Like, how do we find that stuff? All right? So let's get out our calculator here if I can. I still should have it. Yep, here it is. So what we just found was the sine of 30 degrees. Okay? So remember, the big thing about the calculator is if you were talking about degrees, you got to make sure your calculator is in degrees. So mode, scroll down, and go over to degree, hit enter. So now our calculator is set in degrees. Because when I go ahead and I hit the sine of 30 degrees, well, we know the sine of 30 degrees is 1/2. So I'm just going to say 0.5, which we could have easily just said sine of 30. All right. Then we're going to hit the math button. And we want option number 1, answer fraction. And notice it gives us 1/2. Okay. The only problem with the calculator is, depending upon which one you have, it's not going to give you square root of 3/2. So what I mean is the cosine of 30. All right, it's like 0.8 something, 0.866. If you tried to do the same exact thing, but said, hey, put the answer in a fraction, it's not going to do that because the TI-84 doesn't know how to deal with radicals other than approximating them. There are some calculators that exist that will say cosine of 30. When you hit enter, it will say square root of 3/2. But normally the situation is the calculator was programmed from the beginning to show that when you typed in those specific key values. But now what I want to do is I want to think about this in reverse. All right. So for example, let's go back here real fast. Let's say I wanted to find this information out here. All right. And hypothetically speaking, let's say we knew we were at this ordered pair right there. We knew we were at 1/2. All right. So what I'm really asking here is this. Find the angle associated with the ordered pair one half comma the square root of 3 or square root of 3/2. All right. So what I'm really asking for is this. Let's say we had this right triangle and we knew we were right here. The question I'm asking is, what is that angle? What is theta at that situation? Now, obviously there are two ways to do this. The first way, just get out your unit circle. Find the ordered pair 1/2 comma 3/2. And we already know that that is going to be a 60-degree angle or pi over 3 radians. All right, just by looking at the unit circle. But now the question becomes, okay, well, how do you, if you didn't know that, if you didn't have a unit circle, could you use your calculator? And the answer is absolutely yes. What we're going to write is we're going to write this. We're going to say, in this case, let's do cosine first. What is the cosine of theta when it equals 1/2? Now to solve this, we're going to use what we call inverse trigonometric function, inverse trig functions. All right. Now, you have a button on your calculator that shows you this. This course isn't about doing this by hand. We're just going to do it using our calculator. So what we say is we kind of swap these positions, but instead of writing cosine, we're going to write cosine inverse. Now, by doing this, and if we get our calculator out, so let me go ahead, let me get my calculator out here. Let's make sure we got the screen so you can see the screen. If I hit the inverse cosine of 1/2, it is going to say 60 degrees, which is exactly what we wanted. Also, so let me write this down. So 60 degrees equals theta. You could also have done sine theta, but in this case, I'll write it in blue, I'll write it underneath. In this case, it would be, oops, too big. There we go. Sine theta equals square root of 3/2. So what you would say is, well, the inverse sine of 3/2 equals theta. So theta has to be, now, once again, I'm already going to write 60 degrees, like I know that. Okay? So let's go ahead, let's get our calculator out again. And I'm just going to leave this up here for now. So the inverse sine of the square root of 3/2, close the parenthesis. Once again, we get exactly 60 degrees. So there are two ways to go about this. You can use the inverse cosine. You can use the inverse sine. Now, you could even use the inverse tangent if you wanted. But if you wanted to use the inverse tangent, first thing we would have to do here is we would have to find out, well, what is the tangent at this point? And the tangent, remember, tangent is opposite over adjacent, or sine over cosine. So tangent theta is going to equal sine over cosine, square root of 3/2 over 1/2. Now, we can go ahead and simplify this by saying square root of 3/2 times 2/1. 2's reduce. So we have tangent theta equals the square root of 3. And finally, to find, and once again, the answer should be 60 degrees. We would use the inverse tangent of square root of 3 equals theta. So we get our calculator out one more time. And we're going to do inverse tangent. So here's the inverse tangent, square root of 3. And hit enter, and once again, we get exactly 60 degrees. So that's how we can find angles if we know the sides. Or better yet, if we know what ordered pair we're standing at. So the next thing I just want to go over here is, well, what if you don't have the big three? The big three are sine, cosine, and tangent. What if I wanted to find the value of the secant of 28.7 degrees? Okay? Well, if we look at our calculator, all right, initially on the surface here, we do not have a secant button, okay? Also, you got to remember, this is sine inverse. Sine inverse is not secant, all right? So what I want to do here is go back and remember, well, what are we looking at in terms of the trig function? So remember, we have sine theta, cosine theta, tangent theta, and then we have the reciprocals. Cosecant theta, secant theta, cotangent theta. So for us, we are starting with secant theta. We want to get back to this. So what we're going to do is we're going to write secant theta, or secant of 28.7, is equal to, now remember, secant is the reciprocal of cosine theta. Well, cosine theta would be over 1. So the secant would be the reciprocal of that. So this would be 1 over the cosine of 28.7. And when I go ahead and I do the math here, so let me get out my calculator. 1 over the cosine of 28.7. Enter, that is 1. Was it 1.4? I can't remember. Yeah, 1.14. Perfect. So that would be the angle measurement for that one. All right. So it's really not that difficult, like I said, if you think about it. Okay. It's just a matter of remembering how the relationships for all these things work. And that will be it for this video, and I'll see you in the next one.